Assembly code varies from one machine to another. We are going to look at one based on x86-64, which is found in most laptops and desktops today. This stuff may look scary, but it is important to understand. We must now deal with .s files.
She has too many fangs. 2 is the best number. She should give 2 of them to you, and then we would all have the right number of fangs.
I'm the last step before the ones and zeros. I am readable by humans. If you want to see me when you run your code, you can type GCC-OG-S mycode.c into Linux. This will stop the process before assembler so you can see me in all my glory. Some people even code on my level.
Why would anyone put themselves through that? Even I will only talk to you through .i files.
This is the general format for assembly code. The first part of instruction is the directive, and the second part references the registers we are working on. These are the operand. The CPU has 16 general-purpose registers of 8 bytes each. They hold integer data and pointers for very fast access. There are also floating point registers that can hold floating points of more integers and conditional code registers, or DALU. These are the first 8 registers. The ones that start with R are 8 bytes with seemingly random letters after. This is the full size of the registers. If we replace the R with an E, it only refers to the last 4 bytes of the register. If we leave off this first letter entirely, it refers only to the last 2 bytes of the register. For referencing to only 1 byte, we remove the X, if there is one, and add lowercase l. The second half of the registers have just an R followed by the numbers 8 through 15. If we want 4, we add D. If we want 2, we trade the D for a W. And if we only want 1, we use B. We didn't choose a simpler, more consistent way of naming these because too many people were passing the class. Register %RAX is used for temporary data and to store a function's return value if the register is big enough. %RBX, %RBP, and %R12-R15 are saved across function calls, and %RSP is reserved to point to the top of the stack. There is another register called %RIP. That is the program counter. It is a pointer that points to the next instruction in the program. We never put anything else in this register because it's important to always know where we are. Pointers may be annoying, but it will help you avoid that feeling tourists always have in Venice. The Intel data type refers to the size of the word for a type of variable. Even though word sizes are larger on modern machines, we still refer to 2 bytes as a word for this because of its origins. The assembly code suffix refers to what we sometimes stick at the end of commands. This tells the computer how many bytes to interact with. MOV is one of the most important instructions you will tell me. This copies the first register that's written into the second, or one way between memory and a register. We cannot move something from memory to another part of memory in a single command. We can put a Z or S after the MOV to indicate going from a smaller size to a larger. Remember that the registers you are going to and from must be of the appropriate sizes. I'm going to limit you to just these options because I'm mean. With all the Z, all the new bits at the beginning are filled with zeros. Using the S instead, we'll do a sign extension to account for signed variables. For example, MOVSWQ %AX %RDI would take 2 bytes from %RAX and extend the beginning with the most significant bit until you have 8 bytes and put that in %RDI. In this chart, A and B refer to an arbitrary register. Number 1 refers to an arbitrary number called an immediate. Number 2 is a number that is 1, 2, 4, or 8. I know number 2 only having a few possibilities seems limiting, and it is. It's like how ancient Egyptians only ever put a 1 on the top of a fraction, so they had all these weird workarounds to do simple things. This is a way to add extra information to a single line of assembly code. Unlike if we just put the register using parentheses, we'll look for the location in memory that the calculation points to. This will always be shown in hexadecimal. I'm sorry to the mathematicians out there who are cringing at my use of symbols and parentheses. For example, move Q moves 8 bytes from register %RAX. We put this in the address of 5 plus whatever is in %RDX times 4. Whatever that comes out to, we go there and copy %RAX into it.